We reach Step 5, Risk Analysis. We know what can go wrong in the process, its causes and effects from the failure net we built in Step 4, but not every potential failure presents the same risk. In Step 5, we will build a risk profile of the process step to identify the areas of high risk. We will use 3 factors to calculate this risk: severity, occurrence, and prevention. The first factor, severity, pertains to the bad consequences of a failure, ranking its effects. Consequently, in FMEA, we rank each of the failure effects on a higher level. The most common method for doing this is through a scale ranging from 1 to 10, with 10 denoting the most severe situation, such as a risk to the end user. Different tables are used across various industries to define these specific values. For our example, I will base the rankings on common practices. For instance, scrapping a mechanical part is typically ranked as a 7 because though it can significantly hamper productivity, it doesn't pose a risk to the customer or end user. I am ranking the effect nut gets stocked in the screw thread with a 6 because it will reduce the primary function of the nut, but it will still work. And for the effect nut damages the screw threads completely. I am assigning a 7 because this is a complete loss of the primary function of the nut. We continue doing the same for every effect in our analysis. If you remember, the way we identified these effects in Step 4 was through a brainstorming session. Therefore, these are potential effects of potential failures of the process step, and it is extremely difficult to tell for certain which will actually happen or when. The FMEA methodology suggests us to take a conservative approach to define risk and take the highest severity for each failure net. For our example, that means taking 7 for both failure nets on the screen. The next factor is occurrence. Occurrence in simple terms is about how likely is the failure to happen, its likelihood. In an FMEA, we rank the occurrence of the causes of a failure. To do this, we first need to identify prevention controls currently in place that could be reducing the occurrence of this cause to happen. If there are absolutely no prevention controls in place, we can assume that the cause will happen. Here an example. For the failure cause, tool profile angle too narrow, let's assume that there is tool profile maintenance and identification in place. This activity helps ensure the tool profile angle is not too narrow, since someone will be checking and adjusting the tool. So, with this action in place, I say that it is fair to rank it with a 3, which means that it is very unlikely to have this issue, but still possible. The last factor that we need is detection. Detection ranks the ability that we have to either detect the failure cause and react before it causes a failure, or detecting the failure once it occurs and stopping it from creating the undesirable effect. For our example, let's assume there is a first article inspection of the thread angle in place. This action allows us to detect the failure mode before we have many parts produced with the wrong angle. This type of detection control gives low confidence that the failure will be detected because it can only detect when at least one failure already happened, when a part with the wrong angle was already produced. I am ranking it with an 8. Now that we have the 3 factors, severity, occurrence, and detection, we can calculate the risk for this failure net. There are different methods to calculate this risk. For this example, I am using the action priority or AP approach. There are other methods like the risk priority number, RPN. Any of these methods are based on the same idea. A combination of severity, occurrence, and detection values gives us a risk value. In our example, the risk value for this failure net is medium. We repeat this for the rest of the failure nets in the FMEA. We have completed Step 5.